So at this point, my compressor is on, my feed supply from my compressor is under pressure. I open my inlet ball valve and I'm pressurizing this system. My air is not under demand right now as my inlet ball valve is still off. But I'm under pressure at this point, therefore I can set my filter regulator lubricator by opening my inlet valve to the my inlet valve for the fan. And at this point, I'm going to turn this regulator down and I'm going to use 60 psi at this point. And at that point, you can push this regulator knob down, locking it in place. I've already set my lubricator for this unit. If you need to, the instructions for it are in the owner's manual. So at this point, I know that my regulator and my lubricator are set. Therefore, from here on out, I will simply use this ball valve as my on-off for the after cooler. For the rest of this demo, I'm not going to be running my fan for the noise, and my shop air here is extremely dry already, so I don't need this after cooler in my facility. So the next step would be to open this inlet ball valve, which would pressurize my system, and being that my bypass is off, my system will pressurize to whatever my regulator is preset. I believe we're somewhere around 40 psi. So I open the inlet ball valve, and my air is coming into that system through the coalescing filter and through the regulator, again being that my bypass line is closed, and my system has been pressurized to a little under 50. Now notice my blast pressure is at 0 and my differential pressure is pegged all the way over beyond 5. Again, this capsuhelic gauge measures the difference in tank pressure over that of your blast pressure. So being that my tank pressure is 55 psi and I'm at 0 on my blast pressure, this gauge is pegged all the way over. As I engage my nozzle, developing blast pressure, this gauge then will tell me the difference between my tank versus my blast to assist in that abrasive flow if it's needed. So at this point, I'm ready to engage the nozzle, and I'm going to show you the finite capabilities of this system in controlling the tank pressure over your blast pressure by the capsuhelic gauge. Alright, please engage my nozzle, keeping in mind that my gate valve is all the way open, and please watch the gauges. So at this point, the tank pressure is showing slightly under 50, and my blast pressure is showing a little bit less than that. But my capsuhelic gauge is virtually on 0. So I'm having equal pressure in the tank to the blast air. By manipulation of this gate valve, I can change that. Please continue. As I turn in the gate valve, creating restriction in this airflow, you can see how finite of controls I have on that differential pressure. Now, all right, please stop. So I'm currently set at about a 2 psi difference. Experience shows that 1.5 to 2 psi differential is where you should be whenever you're using sodium bicarbonate. Should you require more abrasive than what you're getting, you simply manipulate this gauge a little more to give you a greater differential. If you're getting more abrasive than what you want, you simply open this gauge or this valve also slightly and decrease the amount of differential pressure, reducing how much force is in the tank pushing that abrasive into your airstream. Point to note, if you're in an application where you require higher blast pressures but you still want it regulated, there is not an issue in the world under pressure by taking this regulator up from 60 to 80 to 100. I don't care. But if you're wanting to go from a higher pressure to a lower pressure, you need to shut your inlet ball valve off, depressurize this unit. I'm not going to go all the way. Turn your regulator back out, then open your inlet air again and build your pressure up to where you're wanting to blast. You do not want to allow this system to depressurize backwards. This is your air out, always. If I were on a project blasting at 60 or 80 psi through the regulator, if my application dictated that I wanted to run at full pressure, in lieu of modifying the setting of this regulator, I would simply open this bypass valve, which you can see bypass that regulator and has taken this system up to whatever your compressor is set at. I'm currently at 140 psi. So now, should my operator turn that nozzle on, I would simply verify my capsa helix is set where I want by the adjustment of the gate valve, and he's still in production. If you want to go back down to the same regulated supply, you simply close this, depressurize the unit, bring the system up to whatever blast pressure you want. As I mentioned earlier, the clean out feature on the Thompson valve 2. If for some reason I ended up with a contaminant in that abrasive and it was blocking the orifice that's inside that Thompson valve, I needn't drop the Thompson valve to remove the foreign object. I can simply close this manual shut-off valve. I can open the clean-out valve, and if I were to go hit my dead man, what would happen is the auto air valve would open, forcing my blast air down into the base of the Thompson valve 2. My Thompson valve 2 would also open, but would receive no more abrasive from the vessel because this manual shut-off valve is off. So this air coming through that base would divert up through the orifice, picking up my foreign object and blow it out this clean out. Now we're going to back up a step and I'm going to actually hit the dead man to show you the clean out feature in operation. What you just heard was all of the air coming out of here from my blast hose. If there had been a foreign object in here, it would have been carried out this outlet. By simply closing this and opening your manual shut-off valve back down, your operator is back into operation without having to drop that Thompson valve to remove a foreign object. On the blast nozzle itself, as I said, you have a water outlet that's controlled by this petcock. And all that is water coming out, where if I were to engage that nozzle, that water would keep my dust levels down. It's not going to eliminate your dust cloud, but it certainly does minimize it. Your unit has been ordered with a standard blast nozzle, which is 5/16 or a number 5 in diameter. You have also purchased a number 6 fan nozzle. The fan nozzle itself would simply screw into the nozzle holder until it bottoms out. So you would remove your wet blast attachment by this swivel. And simply install or attach your water hose to the swivel on your fan nozzle, and you're ready to go back into operation.